when I pass current through a conductor, this also acts as a magnet. So it also produces a north and south pole. So and also it's placed in a magnetic field. It also has a north and south pole. So when this electric field and magnetic field creates a torque and force. So ideally what is happening here is there is a circuit here. It has a north pole, south pole, and there's a north here. It attracts and repels, and again keeps rotating. And this is the reversal of this part. So electricity we are rotating it, and the reversal of this process while rotating this we are producing electricity.
Yes.
Which is happening here.
Okay.
By rotating it, so there is the same similar setup inside a motor here, similar to it. So I'll keep rotating. Ta-da!
So now we have an empty balloon and a balloon with gas. We took vinegar and baking soda. We mixed them both. Now we captured carbon dioxide from it. So when we mix both baking soda and vinegar, carbon dioxide is emitted. So now we collected it. Now we will measure the balloon with carbon dioxide and empty balloon. Now empty balloon is 1.47 grams. Balloon with carbon dioxide is 2.68 grams. Now you can clearly see the difference.
Yeah.
It's because of gas.
This, you know the mass of this and volume of this.
Yes. Just to show that gas is high.
Yes.
Okay. Is it the way how do we fill carbon dioxide here? Okay, I know this. We did this in one of the physics activity where you take a bottle and put some acid,
Acetic acid.
and then you put the balloon on top and you capture the air.
Yes, but you have to mix baking soda in it.
Okay.
Then it will emit carbon dioxide.
Carbon dioxide.
Yes. Then you have to capture it.
We did it with magnesium strips.
Oh, magnesium strips. Okay, yeah.
So that's why I don't remember this.
Okay.
And then you captured this, but then the question was this only: how do we measure the air inside it?
That's all. We just wanted to see children to know the difference. It's just 7th class students. We are not making it complex.
Okay.
And we just want to show that gases have mass. Just the difference.
Okay. Gases have mass.
This is the equation.
Okay. Of this. Thank you, Chandu.
Thank you so much.
It's visible?
Yes. Wow. This is the beauty of physics.
Yeah.
At this point, the light is
focal
converging.
length.
Yeah,
This is the
focal length.
point. Here the image will be formed. See, you see it at one.
Yes.
Yeah.
And then it is diverging.
Exactly. So I'll show you one more thing. This is a convex lens. We'll now use a concave lens.
Okay.
So concave lens diverges. Whenever a light falls on it, it just do this way.
A lot more we can see on the surface.
Yeah. So
Yes.
see that the rays are diverging.
Correct. It is parallel,
Yeah,
but then
it's parallel, and then when it passes through it, it diverges.
diverges. Correct.
Whereas in the
One is
convex one, we saw that they were converging.
Yes.
So these are two different lenses
Mm-hmm.
and used for different purposes. That's the reason why this happens. So
Yes.
when they diverge, we feel that the image is somewhere here because this is happening this way.
Correct.
And this is used in the rear view mirrors and all, like you see on the roads turns. Like this is the road, but we see it in the small.
Yes.
So this is the application of this concave lens.
Okay.
Whereas you would have seen people using a magnifying glass or something and burning paper or grass. That is something where you focus everything on that point.
Okay.
All the rays are coming and they get focused on one point.
Okay.
All the sun rays that come and heat are focused at one point, and then this burns the paper.
Okay.
This is focus. This one is diverging. That one focuses.
Yeah. I think I remember these things we used to do in childhood.
Yeah, burning
Yes.
grass and burning paper. Yeah, I've done that. But I never saw this rays thing happen.
No, I agree. I remember now ki we were just learning it in terms of prism, not in light.
Yeah, white light, because of white light you see different colors coming out, but not the
Rainbow colors.
the rainbow colors.
Yes. Thank you. Magnetic pole, how unlike poles repel, and now about unlike pole attract. Yes.
Let's select it too first.
Yes.
How do we want to begin?
Yeah, so we are going to demonstrate laws of reflection. So now generally we learn laws of reflection in 8th grade.
Yes.
So this is a unit plan on light, and this is a part of a lesson which is on reflection. So here we are going to learn about laws of reflection.
Okay.
So how will we demonstrate laws of reflection? I have a plain mirror here, and using a protractor I have used I marked the angle from 0 to 180, both sides.
Okay.
Now I am going to put light on a particular angle.
Okay.
So here I am putting on 40 degree, and in the plane I mark the center and draw a straight line from there, which is at a 90 degree. Now I am putting light on the center.
Yes.
Now you can see that. One second. The light is coming through 140 degree, which
Yes.
is from here if you see it's at 40 degree again. One second. Yeah.
Yes.
It's coming through 40 degree again. So which means that this distance from the 90 degree, this distance and this distance is same. Which is this angle and this angle is the same. Which is the loss of reflection, which is angle of incidence is equal to angle of reflection. This is the first law of reflection.
Correct.
So normally when we tell them what is normal in 8th grade, they may not understand it because it's an imaginary line. So this line, which is the normal, is the perpendicular line between the incident ray and the reflected ray. So now you can understand that there is a normal here also, and the incident ray, normal and the reflected ray are on the same plane. This is the law of reflection, which can be easily demonstrated in schools also with limited resources.
Yes.
Yeah.
Thank you.
So here, this is an experimental setup to demonstrate refraction of light. This is
Okay.
another property of light.
Yes.
When a light travels from one media to another medium, the light tends to bend.
Okay.
See, most of us, like everybody knows that the light travels in a straight line.
Yes.
So you can see here from this side, when I put the light, you can see that the light is traveling in a straight line,
Yes.
right?
Yes.
So but
It is bending.
yes, when you look here, in this medium, when it is going from air to water,
Yes.
it starts to bend.
Yes.
So it should be traveling in a straight line.
Yes.
But rather, it is bending down. So this tells us that when the light travels from one medium to another medium, it has the ability to bend.
Bend.
But why does it bend? Most of them have the misconception that the light has a constant speed, right?
Yes.
But through this we can say that the light does not have a constant speed, but when it moves to different media, the light slows down.
Okay.
So that's why it takes the shortest path. Right. And here we have created a miniature model of this.
Okay.
So because not all the schools would have such
Big,
resources and equipments to do the demonstration. So we have created a miniature model of aquarium using some glass lights and the gum. And here we can demonstrate the same experiment at a smaller scale within the classrooms.
Yes.
And here we have used salt solution, saturated salt solution.
Okay.
That is to use different media that are much more denser or rarer.
Yes.
And here also you can see that when the light passes through this medium, the light starts to bend.
Yes.
So this way the students will be able to visualize these concepts and then it will be concrete in their mind rather than just like drawing through ray diagram and learning it.
Yes. Thank you. How did you like it?
It was really nice finally seeing ray diagrams and actual action. And you know, like you can actually see the rays going. Especially the water.
Whoa.
And the one that Jaga did where you could see the light going because they were putting the dust particles. And they did first plain water, then they showed salt water, and you can see different levels of blending. I was really
Even I liked it. I really liked all the experiments. I personally liked all the ones, but the one which was very interesting was about the light converging and diverging, because in school we have never seen such a beautiful activity in less resources. And here they use only chalk particles, to demonstrate the experiment. I really liked it, and I was so glad to come here. So ये वीडियो था हमारे साइंस एक्सपेरिमेंट. दिस कोर्स वाज अबाउट for 4th years who completed their teaching course in physics. They are BA students and they engage with basic studies for students to how they can explain physics as a concept in a lot more applicated way, because most of the schools don't get a chance to perform activities and then teach students, where they only get to learn the theoretical part of physics, which I feel is very boring rather than doing experiments. Don't you feel the same? Yes, no? So
concepts become so much easier to
Easier.
learn once you
actually see.
it rather than just trying to remember it for the sake of remembering.
Yeah, and exactly. One more thing, I really liked it. Like, doing practically means like students think about the theoretical answer.
Yeah.
And their mind constantly think towards an activity where they can enjoy, and then they come up with more activities. So it is so fun, no?
And they're able to learn so many more concepts through just playing around with those little models and
Yes. Yes, I agree. Thank you so much for being a part of this video. I really enjoyed it with you.
Yes, me too.
And we both hope that this video was meaningful and not much but little. Thank you. Bye. You take care.